in the previous part of functions, part 1 of functions, we have discussed about what exactly a function is. We have also created a program in our C-line IDE, and in that IDE we have written a function. So we know that there are 3 steps to write a function. Number 1 is to write the prototype, and we know that number 2 is the function call, and number 3 is the function itself. So we will write our whole function in the last step. So in this part we are going to discuss the second step in a little more detail. So function call can be of 2 types. Number 1 is call by value, and number 2 is call by reference. So there are 2 ways to call our function. We know that in our main function we write a statement of our function call. Let's suppose the function is cube. So we know that this is the function call. So in the main function, this is the function call. And we know that the actual function is outside this main function, and it will have some operations and a return statement. So we know that inside this cube we will give some values, and this value is passed to the functions. So this is known as passing of arguments. So this is passing of arguments, and in this case when we are going to write, let's suppose this is void cube, and at this place it is int a. So let's suppose int a is here. So this value of 7 will get copied to a. So a will have a value of 7. So we have discussed that in our previous chapter. So this method is known as call by value method, because we are calling the function by giving the values, the actual values. The next one is the call by reference. So we have done this. Next one is the call by reference method. In call by reference method, we are not going to copy the value that is passed at the function call, that is this one. So we are not going to copy this to a, rather we will give a reference to this value. So let's say that in a memory, so let's suppose this is our memory. So we know that all the variables and their values will be there in the memory. So let's suppose this is our main function, and this is our cube function, and now we're going to analyze it memory wise. So let us suppose this is the main function and that one is a cube. So let's suppose in the main function this cube function is there, and the function call, at the time of function call there are 2 arguments, let's suppose a and b. And let's suppose these values are 3 and 4. So this is at the time of you can say function call. So I will write function call here. At the time when now we are going to just copy these values. Let's suppose in the cube function there are 2 parameters, x and y. So this will become 3 and 4. So this is call by value. In call by value case, the values, the parameters in the main function will get copied to the values inside the cube braces. So inside the cube parameters, the value 3 will get copied here. So if we do anything with these values, let's suppose we are changing these values. Let's suppose I make this 3, 4, and we make 4 as 5, or anything. Let's suppose we are changing this value. So if you are changing these values, the values will get changed inside this cube function only. It will have no impact on the main function. So there is no impact here. So this makes sense because you are copying the values here. If you are doing something with these values, if you are changing them, these values will not get changed because these are separate. So this is our call by value method, which we have done before also. In the call by reference method, there is a change that we are going to discuss. So in the call by reference method, let's suppose this is the main function, and again this is the cube function, and let's suppose in the memory we are storing two variables, A and B, which we are passing as arguments at this step. So let's suppose the value of A is 3 and the value of B is 4, and these are the parameters of cube. In this case, we are not going to copy the values here. In this case, we are going to create a reference. A reference is a pointer, or we will discuss it later on in the chapter pointers. But at this point, we are just going to make it simple. We just say that these values are being referenced. That means that you are referencing these values. So the values of x and y will be 3 and 4. But if you make any changes, in these values, you are making changes in A and B because these are not copied but referenced. So this is call by value and call by reference. I can just give you a simple real life example to just remember this concept, call by value and call by reference. For example, you have a book. We know that in our book there are a lot of pages which has page numbers. So these page numbers can be like 1, 2, 3, etc. So these page numbers are just like memory addresses of these variables. We know that our main memory, that is RAM, is divided into a lot of addresses. So it is divided into memory addresses, and all the variables that we are using, in fact the code itself is stored and in the main memory, and wherever it is stored it has a memory address. So it is just like a page number in a book. Our book can be considered as a RAM or main memory, and the memory addresses are the page numbers. So let's say that now there's a teacher who gives you a task. So the first task that the teacher is giving you is to copy page number 3. So the teacher says that you will have to copy page number 3 in your notebook. So what you will do is you will open the book, you will go to page number 3. Let's suppose this is page number 3, and then you will copy it in your notebook as it is. So if you're going to make any changes in this notebook, there will be no change in the book. So this is a perfect example of call by value. Second task that the teacher gives you is to make a change on page number 3. Let's suppose on page number 3 there is some error in the book and the teacher wants you to just rectify it. So she says to make some change in page number 3. So what you are going to do is you will just open the book, you know the address, page number 3, you will go to page number 3 and then you will make a change. So whatever changes you are making, you're making it in the main part, which is your book. So this is an example of call by value and this is an example of call by reference. So you can make an analogy here. If we are changing any values in the function, it is going to reflect the change in the main function. If this is not clear to you, we will implement it and we will see how these differ. So we will implement an example of call by value and we will implement the same example using call by reference, and we will see how they are both doing different things, like how are they changing the values of the main function. So we will implement a program known as swapping of integers. So we will write a function. We are going to write a function swap and we will pass two arguments in this function, int x, int y. So we will create a function swap which will swap the values given to it. So let's suppose the value of x equals to 4 and y equals to 5. So this is before swapping. This is before swap, and after swapping the values of x and y will get interchanged. So let's implement this swapping example using both of these methods in function call. So let's get back to our C-line IDE and just see how it works. So this is our C-line IDE. So the first step is to write the function prototype, and this time we are going to name it as swap, and we will take two integers as arguments. So in the int main function I'm going to declare two variables and I will give some value to these variables, like a equals to 5 and b equals to 6. So now we are going to do a function call here, and this function call will be like this. So we are going to pass a and b in this function call. So this is our main function. Now we are just going to write return 0 here. So this is our function call, and this is, these two parameters are in the main function. So what we are going to do is we're going to pass these parameters, or you can say these variables, to the function. So let's write the function. So since the function is returning something, we will have to declare another variable here, or we can just make it void, and we will just write the function here, the swap function, which will take two values, int x comma int y. So in this you can see here that we are passing the values of a and b to x and y. So this is called by value. So I can write here call by value method. So in the call by value method, the value of x will be 5, y will be 6, and we know that this is the copied value. So what we are now going to do is we are now going to swap these values. To swap these values, we will have to create another temporary variable, and the reason for this, why we are taking a temporary variable, is that when we write, you can see here I'm going to write these 3 lines, and I will explain you what these exactly means and why I am declaring this third variable temp. So it should be x and y, x equals y, and this should be y. And now what we are going to do is we will simply print out the values of x and y. So this is our simple program that swap the two values. So let's discuss about these 3 lines, like what we are doing this in these 3 lines. So in these 3 lines, what we are going to do is, we know that we will have to interchange the values of x and y. So if I will write x equals to y, and then I will write y equals to x, this will be wrong, because in the first line when I'm writing x equals to y, that means the value of x will be equal to y, so the value of x will be equal to 5. So now the value of x will be changed to 5, and in the next step when we are writing y equals to x, y will not get the value 4, y will get the value 5 here. So in this case, the initial value of x was lost. So what we are doing here is we are just going to initialize a temporary variable that will hold the value of x. Then we will change the value of x here, which will be equal to y, and then instead of making y equals to x, we will write y equals to 10. So in this way, we are swapping the two variables, and then we are printing it here. So I will write clearly here that we are printing this, the values of x and y, in the swap function. So this is in the swap function, and let us print the values of a and b here. So we are going to print the values of a and b, and I will write it in the main function. So when we are going to do this, we will see what will be the impact of changing the values of x and y on the values of a and b in the call by value method. So we will see. So let's run this program. So this is the output of our program. So you can see here that in the swap function, the value of x is 6 and the value of y is 5. So you can see here that the values have been swapped. Initially the value of x was 5, but in the main function you can see that the value of a is still 5. It has not changed. So this is an important point here, because we are copying the value is not changed in the main function. This is just like you are telling the student to copy the value of a particular page to another notebook. So let's now discuss call by reference method. So now we are discussing call by reference method. And to discuss that, we need a little discussion about another operator. So the operator that we are going to use in the call by reference method is the ampersand operator. So this ampersand operator is used as a reference to the variable. So you can see here that if you want to refer the memory address of the variable, you can use ampersand and then the value. So if you're writing it like this means that you are referencing A, or you can say you are referencing memory address of A. So this makes sense because if the student wants to access the page number 3, he needs to get the reference of that page, that is 3. So let's implement this and let's see how this will have an impact in the values of the main function. We know that it is not changing the values, but when we will use the reference, the call by reference method, and we will use the reference operator. So I will write the reference operator is this ampersand. So if we will use this operator in front of the variable, the value will get changed. So let's write this reference operator here. So to reference, we have to add an ampersand operator here and here, because we are referencing the values A and B. So if we make any change to X and Y, which we are doing in this, it will reflect it in this main function. So if we are going to swap here, the values will also get swapped here. The value of A will change as the value of X changes. So this is all done with the reference operator, this ampersand operator. This is just like AND. So we know that in the function prototype, we will have to make a change here because the parameters have changed and these are the reference parameters. So we will have to add a reference operator here. So now let's see how this program will change. Let's see if it will just swap the values or not. So you can see here that the values in the swap function has changed to 6 and 5. Initially the value was 5 and 6, and in the main function, since we are using the reference operator here, the values are also swapped. So this is the basic difference between call by reference and call by value. It was an important topic, so that's why I took a lot of time in implementing this program for you. In this program, we have used this reference pointer here. So to reference, you will have to use this ampersand, and remember to make changes in the function prototype. So this program will just make changes in the main function also. So the last thing that we're going to discuss about the functions is the scope rules. So let's discuss about scope rules. The first one is local scope. This is local scope. There are some 3 types of scopes in C++. The first one is the local scope, the second one is the global scope, and the third one is the function scope. So let's see what all these mean. So this is the function scope. So we will discuss these 3 types of scopes using our previous example, which we have implemented in our C++ IDE. So this is our program. So the scope rules are applied to the variables. So these are the variables. So if you are declaring a variable. So this is a variable and this is b. So if you're declaring these variables in a particular function, and how we are doing that, we are using the block of statements. So the variables inside this block can be used only inside this block. That means that you cannot access the values of a and b outside this scope. So the scope means the block of statements. So you cannot use the values of a and b inside this function. Like you cannot write cout a here. You cannot do that. It will give an error. So this is known as function scope because the values, the variables are applied only in a specific function and it cannot be accessed outside this function. So you cannot access these values. So this is known as function scope. So I will write here function scopes. So let's suppose that there are a lot of functions in a program. So if you're writing or if you're declaring any variable, let's suppose this is the int temp variable in this swap function, you cannot access this variable outside this scope. So this is known as function scope. So what does local scope means? And what is the meaning of a global scope? A global scope means that you can access the value of the variables in any function or throughout the program. You can access it anywhere. How can we do that? We can do that by declaring the value on top of the main function here. So we can write const int a comma b here, and we can also initialize the value like it was 6 and 5. So we will write it like this. So now these variables have a global scope. That means that you can access these variables throughout the whole program. Like you can access a and b here. You can even access it here. So you can write this like this. So this is correct. So this is known as global scope. This is global scope. The next one is the local scope, and the local scope is very simple. Let's suppose we say we are going to write a if else loop here. So let's suppose I will perform the swapping only when the value of a is less than value of b. So let's say we are going to do this only when the values of a will be less than b. So let's suppose in the if part you can see that this is the if part, or you can say that this is the if scope. So if you are going to write any variable c here, and now you are going to just display the value of c in the output. So this is eligible because the value of c is a local variable. You can say that this is a local variable or local scope. So you can use this value of c in this scope. If you try to do this, it will be incorrect. It will not be correct. So this means that this is the basic difference between our local scope, function scope, and the global scope. So this is clear that the function scope is nothing but when you are declaring variable in a specific function, you cannot use it in other function. In the global scope, you can access the variables anywhere in the program. So you can access variables anywhere in the program. So, and the local scope is local to a block of statement, you can say. So this is the basic difference between local scope, function scope, and global scope. So the variables inside this local scope are known as local variables. The values in the global scope are known as global variables. So we have covered the topic functions, and we will discover more and more functions as we will move on to the next tutorials. But this is the last part of the functions, and in functions we have discussed what a function is. So we know what is a function. We have done that. We know how to write a function in C++. So now we know how to write function in C++. A function can return a value and can be void too. So we have also done these two programs. Then in the function call step, we have done call by reference and call by value. And we have also discussed some scope rules. So this is the end of the second part. Thanks for watching.